Okay, so new section here. This is going to be section. Okay, this is going to be section 1.5. And these are quadratic equations. Okay, section 1.5. So what is a quadratic equation? Well, it looks something like this, doesn't it? Something like this. Okay, so you have an A, B, and C, and you may not even have an A, B, and C. This is just the full version of the quadratic equation. But the whole thing is that you have some type of x squared term, okay? The x squared term means it's quadratic, okay? So typically you have numbers here. You have something like this, x squared minus 7x plus 10, and that's equal to 0. Okay, and you can always identify your A and your B and your C, just like this. Wonderful. Okay. Here's example 1 from the book, okay? Solve by factoring, example 1a. So we have 4x squared minus 2x, and this is equal to 0. All right, well, what do you do here? Well, we can factor out a 2x, okay? If we multiply the 2x times the 2x, we'll get the 4x squared, okay? Then we can have this right here. All right, so 2x is actually equal to 0, and then 2x minus 1 is equal to 0. So here you're just going to get x equals to 0, and then here you're going to get, so x equals 0 and x equals 1/2. And that's what we're going to get for that. Probably should make a new folder here. Notes 5. Okay. So here's some more examples, okay? So what if we have this, B? We have 2x squared plus 7x, and that's equal to 4. Okay, all right. Well, we can move that 4 over. This is a little tricky, so does anybody remember how to do this? Remember, when you have a coefficient bigger than 1, all of a sudden everything is different. So it's a little tricky, it's a little weird. Let's see here. So what you do is you say 2 times 4, that's going to be 8. Okay, wonderful. Then you say 8 and 1, okay. And we can say a plus 8 and a minus 1 right here. We can divide by 2, okay. So this is an x plus 4. This is also an x with a 1/2. So you just take the opposites of these, x equals -4 and x equals 1/2, and then there it is. Okay, excellent. What about something like this? What about with the square root property? So there's a square root property here. What if we had something like this? 3x squared minus 15 equals 0. So 3x squared minus 15 equals 0. How do we solve this? Does anybody know how we solve this thing? Well, I can reduce some stuff real quick here. So I can get this. And then this is actually just plus square root of 5, and this is actually minus square root of 5. Okay. So what do we get at the end of the day? Oh, we just get this. We get x is equal to plus or minus square root of 5. Okay. Wonderful. So let me see if I can copy that thing. Copy this and paste it over here. Okay. Okay, now what about this? What about this example? We have 9x squared plus 25, and this equals 0. How do we do this? Well, let's move the 25 over. Let's divide by 9. We have x squared equals square root plus or minus of 25 over 9. And we all know this is just 5 over 3. So 5 over 3, and then that's it for that one right there. Also, if you have a negative, and I did this in my notes, guess what you get? You get a special little I as well. Okay, so you have to watch out for this sign when you're taking a square root. If you're taking a square root and there's a negative, you're going to get an I. Okay, what about this guy right here? So we have x minus 2 quantity squared equals 6. We could multiply this out and do it like that, or we could use the square root property and do something like this. Okay. So now we have 2 plus or minus square root of 6, and there it is. Okay, so how does everybody feel about that? Does everybody like these problems? Any questions? Does everybody understand what I'm doing? Okay, now there's something called complete the square, and everybody loves this one. Everybody loves this one, but also everybody forgets this one. That's the whole point of completing the square. So we have x squared plus 8x plus some magic number, okay? So usually you'll have 2 terms, or you might actually have 3 terms, but you're always adding a special term here to make this a perfect square. So what's the formula? Well, the formula is b over 2 squared. So what's the b here? 8. So 8 over 2, and then square it. So 8 divided by 2 is 4. 4 squared is 16. Okay, 16. Now, that means that we get to write this thing as a perfect square. But how do we know what number goes here? Well, it's the same number that's here. Whatever number is inside of here, that's the number that's going to be right here. So what is 8 divided by 2? Just 4. There it is. And if we take this and say x plus 4 times x plus 4, what are we going to get? X squared, right? And what are we going to get here? 4x. What are we going to get here? 4x. And then what are we going to get here? We have 16. So is this the same as this? Well, if you take 4 plus 4, doesn't that make 8? So yes. Okay, what about this one? We have x squared minus 7x and plus some magic number. So how do we find the magic number? Well, we do that thing again. We take this one, divide it by 2, square it, and let's see what we get. Well, it looks like we get something like this. Okay, so how would we write this? Well, remember, it's the number inside. The number inside, before you square it, that's going to be this number. So this is the number that makes a completed perfect square, and you can factor it like this. Okay, cool. Okay, so what if we actually wanted to solve something? Okay, what if we wanted to solve something here? What if we have this? Okay, so a is equal to 9, b is equal to negative 6, and c is equal to negative 4. Okay, so the formula is what? Negative b plus or minus square root b squared minus 4ac all over 2a, right? Okay, so the negative and the negative will cancel in the 6. Then we have 36 here for the b squared, then the 4, then the a, then the c, okay? And then over the 2a, okay? So let's see here. What is this going to be? This is going to be 36, but what is this? I think this is actually negative 4 times 36, or plus 4, right? Negative, negative. So 4 times 9 is 36. Okay, so 4 times 9 is 36, but then we have a 4 in front of it. Okay. And this is all divided by 18. So what we can do is we can rewrite this up here and say 6 plus or minus, and this can actually be 5 times 36 over 18. Okay, so this is 6 plus or minus, square root of 36 is 6, okay? And we have over 18. And of course, we can reduce this down because 6 goes into 6 one time, it goes into here, and it goes into here 3 times. And then guess what? That's what we have left over. So, what do you guys think? Does everybody see how that works? Okay, solutions to quadratic equations. Okay, so solutions to quadratic equations. So let's look at this. What if I have this? How many solutions are there? 2 solutions. Okay, wonderful. All right, well, what if I had something, like this? How many, how many solutions are here? Guess what? There's no solutions. All right. And then what about something like this? What if I do this, where it comes down and just hits one time? Then guess what? We have a 1 solution here. All right. So what are the options? Well, you have 2 solutions, no solution, or 1 solution. Okay. So does anybody know how this is tied into the quadratic equation? Well, okay, so there's this special thing right here called the what? Discriminant. Okay, so the discriminant, this b squared minus 4ac term, this thing is really important. Now, you can actually connect this with all of these different solutions here. So let's see if we can figure that out, okay? So if this thing is bigger than 0, okay, look what's in front. We have a plus or minus. So if this is bigger than 0, then this is probably going to be the 2 solution case, isn't it? Okay, wonderful. What if this is less than 0? Yeah, what if this thing is less than 0? So, okay, let me just extend this. This is actually a really good question. Okay, so if this thing is less than 0, then guess what you get? You still get 2 solutions, because if this is a number and you have a plus or minus in front of it, you still get 2 solutions, but they're the complex solutions, right? Complex solutions. So what do we know about the complex solutions? Well, the complex solutions aren't actually zeros. That's when the graph doesn't hit the other function. And you have to think, when you're comparing these to 0, you're comparing this quadratic graph to actually y equals 0, and you're looking for an intersection. So you're actually looking for if this thing intersects with this thing. And what you end up getting is imaginary numbers, because there's no real solution here. So that's why when this discriminant is less than 0, there's 2 complex solutions. So pretty neat, right? Okay, so I'm going to just write i's. Okay, Now, what about when this thing equals 0 perfectly? Well, that's going to be the one solution. Okay, the one solution is when it's going to be this discriminant is going to be equal to 0, and there's just going to be one solution, and then that's it. Because what's going to happen is when this is equal to 0, the plus or minus does what? The plus or minus goes away, and you just get negative b over 2a for the one solution case. And then that is what? I think that's also the vertex, right? So this is giving you the vertex right here. And if this thing, this quadratic, hits the x-axis, then of course it's going to be one solution, and of course it's going to be the vertex. So anyway, so that's how you do that. So discriminant, very interesting, okay? And also there's whatchamacallit, there does exist a formula for the x cube, for a cube polynomial. So I don't know if there's a discriminant version on that one, but that would be something to go look up. Go look up to see if there's a discriminant analog for the x cubed version. Okay. So let's look here. Let's look here at this. How do we factor this? Take 10, okay. And then what two numbers make 10? Well, 2 and 5, okay. 2 and 5, okay. What are the signs going to be? Well, if this is negative, then the bigger number needs to be negative, because negative 5 plus 2 is equal to 3. So you set both of these equal to 0 right here. Okay. So we have negative 2. And we have 5. Okay. That's it. That's how we factor that. So that's a quadratic that we factor. It's always nice when they factor. You don't want to use the quadratic equation unless you absolutely have to. You can use it, but you know, it's always easier just to factor, if possible. It's not always possible. Okay. What about this? So we have 36. Okay, what numbers make 36? 9 and 4, right? 9 times 4 is 36. What if I have these together? Do I make negative 13? Okay, great. So then we have this, and we have this. So we have x equals 9, and we have x equals 4. And that's how we do that. Okay, so here is one, okay, and this is how many solutions could two quadratics produce? Okay, so let's say you had two different quadratic functions, okay? Between those two different functions, how many solutions could be made? Well, here's a quadratic and here's a quadratic. How many solutions? The solutions are the intersections. So this is going to be one solution. Okay. Now, what if I had this? What if I had a quadratic and then I had the exact same quadratic on top of the same quadratic? So how many solutions? Well, an infinite number of solutions. Anytime you have a function that's the exact same function as itself, well, you can have infinitely many solutions. How about this one? What about this one right here? How about no solution? Okay. So this is a no solution right here. Why is it no solution? Are they intersecting each other at any point? Nope. If they're not intersecting each other, well, then it's a no solution. What if we had something like this? Okay, we would have one solution, another solution, two solutions. So, and of course, you could always probably have something on its side, right? You could always probably have some quadratic on its side. I guess you could do something like this. But see, the thing is so you might be able to do something like this, but the thing is that this has to be, it's not a proper function, okay? So this one right here, this sideways u, would not be a proper function, and yeah, so these would be the proper functions. So these are the possible outcomes that you can have right here. Could you have something that has maybe three solutions? I don't know. I'll have to think about it. But you also have to think, you have y equals x squared, right? And this is y1. And then let's say you have y2, and this is, ax squared or something, and this is bx squared. Could you really combine these things? Could you show, this is geometrically, but can you show that these things right here, could you show that maybe there, all the different types of solutions that you could get here? Because, well, because you can have, so like here, you can plug in numbers for x, okay? I can plug in, 1 equals x, right? Okay, but then also a and b would have to be 1, 2. So the whole thing is that, let's do this, okay? What if I had this? We're gonna try something out here. What if I have 3x squared, and this is 1/3 x squared, okay? So what would be the answers here for this? Well, we can always find something that works, but I think this would just be a one solution case. I don't think we would get anything weird here. Well, anyway, so, okay, so one challenge is to try to see, it's easy to draw them out, but try to see if you can come up with something. Yeah. So this case right here, this is this, and this is this, okay? With only one solution right here at 0, okay? So, but you can think about it. How would you prove these numbers? How would you prove 1, infinity, no solution, and 2 solutions algebraically? And then see what you get. Okay, that's it for today. Anyway, so we will probably do another lecture